Welcome all. Our next video is enabling NAT to the outside. In the previous video we looked at connecting two networks. In this video we will configure ETH2 to receive an IP address via DHCP and use IP tables to enable NAT on packets heading out through ETH2. Connecting two local networks is useful, but these days it's more common to want to connect a local network to the internet. The basic concept works the same, but with the necessary addition of NAT, which stands for Network Address Translation Table. NAT rewrites your packet headers in order to make them appear as if they come from your router, thus effectively hiding your system's address from the destination. Let's see how to do it. Create a third NIC, ETH2, on server 1 and connect it to your cable modem, or ISP's router. Configure ETH2 to receive an IP address via DHCP. Use IP tables to enable NAT on packets heading out through ETH2. Let's now see how it works. In the last video we discussed how in order for two systems on different networks to be able to talk to each other, they need to have routes defined, which will forward packets to a router that can deliver the packets to the appropriate destination. The same is true on the internet. If server 2 attempts to contact an IP address on the internet, for example Google's name server at 8.8.8.8, your router will pass them on to the destination. Let's give that a try. No responses were received. So what went wrong here? You'll recall that I said the IP addresses that we were using were defined by RFC 1918 as internal IP address space. Due to this, these IP addresses are not directly usable as internet hosts. In our example, one of two things will happen. Our router will send packets out of the internet-facing interface, where it will travel across the internet to our destination, which will respond to the packet. The response will not be able to find its way back to our system due to the unrouted nature of the destination. Our router will send the packets out of its internet-facing interface, where the next hop will drop the packets due to the implementing egress filtering of traffic with invalid source addresses. IP tables is a command line tool in Linux for interfacing with the Linux kernel firewall, which is implemented as part of the NAT filter subsystem. Let's break down the first command line. The -t option specifies the packet matching table to use. In this case, we're going to use the NAT table. -a indicates that the specified rule should be appended to the selected chain, which in this case is post-routing. The post-routing chain is processed after the kernel handles packet routing. -o specifies the output interface. In our example, the ETH0 interface contains the internal IP systems, and ETH2 leads to the internet. -j specifies what to do if the packet matches the rule. In this case, we're going to masquerade the packet, modify the IP, put them together, and we have matching packets heading out on ETH2, rewrite the source IP address, and track it in the NAT table. The second command is added in the -m command, which matches a packet properly, in this case state. For the packets that came in on ETH1 from the internet and destined to ETH0 LAN, check to see if they are related to or are a part of an established connection. If so, accept the packet and assign it to the forward chain. The forward chain handles any packet that is being passed through your router rather than the packets originating from the system output chain or packets destined to your system input chain. Finally, any packets that come in on ETH0 LAN and are heading out on ETH2 internet are just automatically accepted. Nice! In this video we learned enabling NAT to the outside. In our next video we will learn setting up DHCP.